Hello, my name is Ivan, and my project, obnoxiously named DeepAttraction, attempts to come up with a model that would predict how attractive a given photo is. And the data here is provided by Michael Tom from his app Radiate. The idea was inspired by Andrei Karpathy's blog post where he mined selfies from the web and used some clever heuristics to roughly approximate how popular they were. In a similar fashion, we use ConvNets pre-trained on a much larger computer vision dataset and a transfer learning approach. The key distinctions here are first, not only we use Inception pre-trained on ImageNet, but we also use the same architecture pre-trained on facial data. We also used mean squared error loss, which is more sensitive to fine-grained differences in the data than simply bucketing. And finally, and most importantly, we have robust proprietary labels that come from people making explicit judgments, swiping like or dislike on each other. The problem statement is given a photo and no other information, predict the ratio of likes to likes and dislikes, which we use as proxy for attractiveness. We used squared error loss weighted by the total number of swipes a user has, which actually varies quite a lot user to user. And as a simpler but still interesting experiment, we attempt to predict the gender from a given photo. In this case, using log loss for training and simple accuracy for evaluation. So the data is coming from Radiate, which is an app for iOS and Android, connecting people going to the same music festival. It has Tinder-like swiping mechanics, left, right. It has 100,000 users and about 40 million swipes, which we post-filter to only keep the main profile of a user and the swipes that relate to that photo. To provide some context on how the labels are distributed, here are the label ratios averaged by the user being liked or disliked and the user liking or disliking. In this case, the data roughly matches Andrei Karpathy's finding that women are liked more than men, but roughly speaking, all the values are kind of in the middle of 0 to 1 range. So since no previous baselines seem to exist for the problem, our goal was mostly to do a first attempt at exploring it, and the concrete questions were, can we come up with models that would perform well subjectively? Second, can we do that using existing state-of-the-art computer vision models, but no task-specific architecture engineering? And then finally, would there be any benefit to using FaceNet over Inception? And as a note, Andrei Karpathy found no benefit from that, which was very surprising. All of our models are loaded pre-trained, and then we build either 1, 2, or 3 fully connected layers on top of it and fine-tune using our own labels. An important subtlety to understand here is that FaceNet needs a segmenter model to run on an image first to provide bounding boxes for faces. And since some photos had either 0 bounding boxes or more than 1, those had to be thrown away. And we essentially had 2 evaluation setups with train, dev, and test. Because if we were to just compare Inception and FaceNet on separate datasets, that would not be fair. Moving on to evaluation results. The baseline for gender accuracy prediction is 58%, which is just the most frequent gender. And then Inception does a lot better, and it does slightly better on that subset I just described, which kind of makes sense because it's probably a set of simpler images with less group photos and so forth. But then a FaceNet is a lot better on that same subset, so we see a benefit here. And for attractiveness ratios, we have a baseline, which is just a single best constant prediction. then its inception lowers the squared error roughly tenfold compared to that, and then on the subset, it's slightly better still, but then FaceNet is way better on that same filtered subset. Now the fun part, subjective results. The highest predictions are FaceNet on test set, roughly match what I would expect subjectively. The lowest predictions, I guess as well. The interesting part here is that it's not just a male versus female issue. The ConvNet actually learns the features of unsuccessful photos, like sunglasses or bathroom selfies or unintelligible photos. And this effect would be even easier to see if we look at the middle value predictions where there's mixed genders. And finally, in the bottom row, we have gender misclassifications, which is mostly either group photos or outright wrong labels. So there's not too much to worry here. To conclude, we've seen great progress using a transfer learning approach, which is exciting and counterintuitive. It turns out we can start with a small data set, skip weeks of training, and come up with a good model that's trained in 20 minutes. The mean squared error loss reduced tenfold using ConvNet compared to a simple baseline. And contrary to previous preliminary findings, we see that a neural network pre-trained on facial data yields significant improvements over that same architecture pre-trained on ImageNet.